All right, so today we're talking about writing equations. The first lesson in chapter 2. Today we're going to translate sentences into equations, and we're going to translate equations into sentences. So the Daytona 500 is widely considered to be the most important event of the NASCAR circuit. The distance around the track is 2.5 miles, and the race is a total of 500 miles. We can write an equation to determine how many laps it takes to finish the race. So to write an equation, you identify the unknown for which you are looking and assign a variable to it. Then write a sentence as an equation. Look for keywords such as is as much as, is the same as, or is identical to that indicate where you should place the equal sign. So consider the Daytona 500 example above we just read. It says the length of each lap times the number of laps is the length of the race. So we could let L represent the number of laps in the race. And we know that the length of each lap is 2.5. We don't know the number of laps. We know that the operation is times. And is tells us that it's going to equal. And we know the length of the race, which is 500. Okay? So 2.5 times L equals 500. So let's look at a couple of examples. We are to translate the sentence into an equation. 7 times a number squared is 5 times the difference of k and m. So let's break that down. 7 times, so that's our operation. A number squared would be n squared. Is going to be equals 5 times, that's our operation again. The difference of k and m would be a subtraction problem. So when we have the difference like that, we're going to put parentheses, and we're going to put k minus m, k and m, okay, in that order. And so then it would just come down to 7n squared equals 5 times, in parentheses, k minus m, okay? Let's look at another one. It says 15 times a number subtracted from 80 is 25. So I can rewrite the verbal sentence so that it is easier to translate. 15 times a number subtracted from 80 is 25 is the same as 80 minus 15 times a number is 25. Let n represent the number. So I know 80 minus 15, that's going to, minus is my operation, and then times, again, my operation, a number, and we're letting that represent by n, is my equals 25, okay? So the equation would be 80 minus 15n equals 25. All right, so from your notes, let's look at the 2 more examples. Translate each sentence into an equation. 10 times a number, x, so they're giving you the variable right here, number x, is equals to 2.8 times the difference of y minus z. So 10 times, so 10, then the operation multiplication on the number x. Then it says is, so that equals to 2.8 times, so 2.8 times the difference, so we have a subtraction problem, of y minus z, okay? And then put it all together and write your equation. All right. Then we have a number m, again, it's giving you your variable, minus 8 is the same as a number divided by 2. So a number m, so I could say m minus 8 is same as, is my equal sign, a number n divided by 2. And then I could put it all together, m minus 8 equals n divided by 2, and I could also write it like this right here, n over 2, okay? All right, so you try these 2 and then come back and see how you did. All right, so let's see how you did. You have 3 times a number t minus 12 equals 40. So let's put it together. 3t minus 12 equals 40. And then the next one, 1/2 of the difference of A and B is 54. So 1/2 A minus B equals 54. Okay? All right. Now let's look at a word problem. It says use the 4-step solving plan. The population of the United States in July 2007 was about 301 million, and the land area of the United States is about 3,500,000 square miles. Find the average number of people per square mile in the United States. So, you know that there are 301 million people. You want to know the number of people per square mile. So I can write an equation to represent the situation. I'm going to let P represent the number of people per square mile. So I could say 3,500,000 times P equals 301 million. Now I just need to solve that. So I would divide both sides by 3,500,000, and that's going to give me P equals 86, or 86 people per square mile. And then to check that, all I have to do is go back to my original equation, the 3,500,000 times P, plug 86 in for P, multiply it out, and it should equal 301 million. And it does, so that would be the correct answer. All right? You can try 5, see what you come up with, and then we'll go over it together. All right, let's see how you did. So if P represents the number of pounds he wants to lose, write an equation to represent the situation. Well, I know he weighs now 160 pounds, and then I need to subtract P, how many pounds he wants to lose, because we know how much he wants to weigh of 150 pounds. So then all I would have to do on this one is I could subtract 160 from both sides, and that would give me negative P equals negative 10, and then just simply divide by negative 1 on both sides, and positive P is going to equal 10 pounds. Okay? So the answer, his goal, would be 10 pounds. Now, a rule for relationship between certain quantities is called a formula. These equations use variables to represent the number and form general rules. So we translate a sentence into a formula. For example, the area of a triangle equals the product of 1/2 the length of the base and the width. So we know we're looking for the area of a triangle, which equals the product of 1/2 the length of the base and the height. Let A be area, B be base, and H equal height. So we're looking for the area, which equals 1/2 times the base times the height, or A equals 1/2 BH would be the formula for the area of a triangle. Okay? So let's look at another example. The area of a rectangle equals the length times the width. Translate the sentence into the formula. So let A be area, L be length, and W be width. The formula is area equals the length times the width. So A equals L times W, or A equals LW. Okay? So try the next one. The area of a circle is the product of pi and the radius r squared. All right. So if we're going to let A equal area, and we're going to let r equal radius, then it would be area equals product, means it's multiplication of pi times radius squared, or A equals pi r squared. Okay? All right. Now we're going to write sentences from equations. So we're going to go the other way. Okay? If you're given an equation, you can write a sentence to create your own word problem. So translate each equation into a sentence. 6z minus 15 equals 45. So we just write that out. 6 times z minus 15 equals 45. And then y squared plus 3x equals w. So this is an addition problem. So I could say the sum of y squared and 3 times x is w. Okay? All right. So let's look at another one. Translate the equation into a sentence. 4n minus 8 equals 12. So 4n would be 4 times a number, or 4 times n, minus 8 would just simply be minus 8, and then equals is equals 12. Okay? And then a squared plus b squared equals c squared. I could say the sum of the squares of a and b, because that means it's an addition problem. Both of them are going to be squared because it's the sum of the squares of a and b equals, or is, so is equal to the square of c. Okay? So it's just breaking it down. So there's 3 here. You try these 3 and see what you come up with. Okay? So 4a minus 5 equals 23, 6xy equals 24, and c equals 5/9 times the difference of f and 32. All right, so the first one would be, let's see here, 4 times a minus 5 equals 23. Okay? On the next one, I could say 6 times x times y equals 24. Okay? Okay, and on the last one, I could say c equals 5/9 of, oops, messed up, didn't I? 5/9 of the difference of f and 32. Okay? All right. So we can write problems based on given information also. So for example, if I have been given t equals the time that Maxine drove in each turn, t plus 4 the time that Tia drove in each term, and I'm given an equation. 2t plus the sum of t plus 4 equals 28. So I need to write a problem based upon that information. I could come up with something like Maxine and Tia went on a trip, and they took turns driving. During her turn, Tia drove 4 hours more than Maxine. Maxine took 2 turns, and Tia took 1 turn. Together, they drove 28 miles. How many miles did Maxine drive? So in my word problem, I encompassed all of that. Okay, so Tia obviously is T. She took 2 turns. That would be 2 times T. And then Tia took 1 turn. So that's T plus 4. You're adding them together and getting a total that they drove together of 28 hours. Okay, let's look at one more. F equals the cost of fries. F plus $1.50 is the cost of burgers. And F times the sum of F plus $1.50 minus F equals $8.25. So I could write a problem for that. The cost of a burger is $1.50 more than the cost of fries. 4 times the cost of a burger minus the cost of fries equals $8.25. How much do fries cost? Okay, so that encompasses everything. It's not as detailed of a story as the sample problem in the first example, but it's a problem, a word problem that encompasses all of the information that was given. Okay, so that's how you'd work those types of problems. All right, if you got any questions, email me. Otherwise, have a great day.